Welcome to Android Dialogues, where we have bite-sized conversations with people in the Android community. I'm Huyen Dao, and I'm speaking with
Lisa Luo.
Lisa, thank you so much for joining us today.
Yeah, it's great to be here.
Well, where are you based, and how did you get started in Android?
So I'm currently based in Brooklyn, New York, and I got my start with Android, I'd say in college. I took a smartphone programming class, and it was literally just called smartphone programming, and it was the first time it was offered, so we didn't know if it was Android or iOS. And it turned out to be Android, which I think a lot of people were disappointed with. I don't know why. I was pretty indifferent. I think our professors were just more old school and into Java, and it was just easier to get started with Android because they didn't want to deal with licenses.
Makes sense.
So that was actually my favorite computer science course. And then when I was an intern at Kickstarter, I was actually working on the back end in Rails. But for Hack Day, I realized that, well, my Rails skills, I don't really feel that good about them because I was still learning. But I really did like Android. And Kickstarter at that time did not have an Android app. So for my Hack Day, I just hacked together it was basically just a web view that sent some headers to cut off certain parts of the web view and render the Kickstarter website in a web view in a different format, and that was exciting for people.
I'm so happy to hear that you were excited by web views, because usually that's not the reaction that people get. But
yeah,
it's cool.
I just had a few hours, so I was like, what can I just want this to render natively on a device,
right?
So that's what I ended up doing, and yeah, we were all excited about the web views.
When you're doing a hackathon or hack day, then it's just whatever works.
Yeah. So that was the MVP for Hack Day, which is
not MVP, most valuable player, not the other. Sorry, I was my brain went to the architecture for a second, but no, you meant
the minimum viable product.
Oh, minimum viable product. Yeah. Then I started thinking about model view presenter and most valuable player.
Yes.
I guess you were the MVP with the MVP.
Yes, I was the MVP with MVP.
Unfortunately, you didn't use MVP, I guess, at the time.
I did not get to using MVP. That would have been an achievement unlocked, I think.
Where are you working now?
So I'm currently still at Kickstarter, but I will be starting soon at HQ Trivia, helping get Android out the door, which I'm very excited about.
So I know you were talking about in your class how your professors were into Android and the rest of the class didn't. And I think that's interesting because right now you're actually doing both Android and iOS, right?
Yeah, so when I returned full-time to Kickstarter, this is story time, my first project was just to ship Android 1.0 with our native team. And we did that and we released our app in 2016, which was really exciting. It was Kickstarter's first official Android app. And we built it using RxJava and MVVM, which is Model-view-viewmodel. It's alphabet soup. Yeah. But it was really interesting because when I joined RxJava, the team was already leaning towards that and MVVM, and that's not really something you learn in school, especially a few years ago.
No, absolutely, yeah.
So when I heard the news, I was actually pretty excited because I asked a few questions. I was what is RxJava? It's just something that's so new to me. And when I learned that basically the principles we were taking most from it was that we the mathematical principle of functions, input-output relation functions that limited mutability and side effects. Hearing that was just whoa, I don't know what this is. It looks really scary, but honestly, anything is better than the Android development standard right now, or at least how I learned it in school, and at least from projects I've seen that have are huge view holders with async tasks and these huge switch cases that just handle all the state of how views are rendered. So that was pretty cool. I'd say for our team, we were 2 Android engineers and 2 iOS engineers, and it was mostly we worked very collaboratively together. This framework was new to all of us, and it took us so many tries to get it right. A view model, basically what a view model is it's a class that holds all the business logic that handles things also API requests and just processing data. The models we used were just AutoParcel, parcelable models from our API. And then our views were included activities. When we began, it just included activities. We didn't have any fragments yet. We had one fragment at the end, and it was great. We like fragments at Kickstarter.
That's refreshing to hear. I always like to hear both sides, Always like to hear both sides of the argument.
Yeah. Both sides make sense, honestly. Like, it's just like more life cycle things to handle, but I think with our architecture, it really worked well with our architecture. Just like we have like base classes. Oh, and a fun thing too is Kickstarter, both of our apps are actually open sourced. So if you want to ever pause and take a look at them, it's Android OSS, like /Kickstarter/Android OSS on GitHub, and that's pretty cool. So you can look at like how everything is architected. But what I was saying is we had a base activity and we just modeled a base fragment after it, but I won't get in too deep with fragments because
that'll start a little bit of a war.
I'm honestly pretty indifferent, so that's also why I'm like,
I think it's a good way to be, like, trying to be, like, just kind of more even-keeled and just seeing if it actually works for your particular situation. If it doesn't, then that totally makes sense. If it does, also makes sense.
And there's definitely, like, a need for them, right? Like, there are, we use a view pager with, like, a tab layout, and that's just, like, a use case that makes total sense. Like, we want that container to be a fragment container to be replaced and, like, to have a parent. So there's some cases where it's just, like, I don't know how I would even go about fighting this, and it works pretty well, like, so that's our one fragment. It's our discovery.
So do you actually have, like, I guess, the parallel, do you parallel that architecture between your Android and your iOS?
Yes. Okay. So back to the story. Is once we released our Android 1.0, we looked at our iOS app, which at that time was still totally written in Objective-C by one person who was sort of the tech lead on our native team. And at that point, that was the biggest Kickstarter's native team had been. It was 4 people. We looked back at the Objective-C app and realized that, like, learning, this was 2016, like, having us learn Objective-C seems kind of pointless, or just seemed like not to be like antithesis of like sort of the functional programming that we were embracing. Like, Swift is just very first class with a lot of functional concepts. And it was also like a one-person code base, so we just decided then, like, it was a pretty easy decision for us to just sort of scorched earth, like, do a complete rewrite of the iOS app. And we did do that, and it was totally inspired by the way we architected Android because we liked using RxJava so much, and we really liked MVVM, but mostly, like, the main reason why is because all the business logic was extracted into these, like, pretty agnostic classes. Like, they only know about their view once we, like, tell them. Right. And they had inputs and outputs that were very clearly defined. So, like, an input would be, like, on a screen, a user touches a button. So then an input would be button clicked. And then the output would be maybe we start an activity, maybe we do something. And then that output would just tell the view to start an activity. Right. So it was this very cool flow architecture. And we remodeled Swift the exact same way. We used ReactiveCocoa, and, like, a lot of people ask why we went, now it's ReactiveSwift rather than RxSwift. And it's because we found that RxJava is great, but it's pretty much, now there's RxKotlin, but that was pretty much the only, like, reactive framework for Java, or for Android at that time, that we liked. But it's also pretty heavy. Like, there are a lot of operators and things we didn't use. And then when we looked at ReactiveCocoa and RxSwift, we made the decision that we liked what ReactiveSwift had to offer. So that's just, like, a caveat.
When you're developing a feature, for instance, how closely, like, I mean, do you actually try to almost make exactly the same structure and just, like, the analogous, like, constructors on both sides?
Exactly. So when we were building Swift, like, then our whole team, like, switched over. We wanted to build this app pretty quickly, and we all were pretty fresh off of building Android. It wasn't uncommon for my workflow to literally have Xcode open and Android Studio open, which I know is blasphemous, but I asked for an hard drive upgrade. The view model class is, like, it's a class in Android, but then it's just, like, protocols and Swifts, I think. Yeah. So sometimes I would just literally have them open side by side. And because, like, the models were the same, it was the same code base. And the views, basically you just swap out, like, view controller or cell for, like, activity or view holder. And then within the two like reactive frameworks, like instead of observables in Android, it would be signals in Swift. So aside from those little differences, like line by line, like it was very similar. It was really easy to use our Android as a blueprint to build Swift.
So that's really cool because you have that kind of abstraction, and then the abstraction can be very, very similar because the languages are similar enough, and then the implementation details of the platform you can kind of push off to like the other, like the
and even layers. With Java 6, it was like cool to build that. I mean, like the transition now obviously is like Kotlin. We had actually known about Kotlin when we were building Android, but it was already hard enough to like figure out RxJava that we didn't want to like do RxJava and Kotlin while we had a deadline to just like ship our Android app. So, but it was something that we'd always been thinking about because we like functional reactive programming principles of just like mapping and like immutability and like cleaning up state. We did look into Kotlin, and that was always in the back of our minds. And I think only after like the Android developers on our team went into working on Swift did it really click. Like, wow, like if we can already build up two apps very similarly, just like by keeping our business logic in like there's certain classes and writing tests on them in Java and Swift, like looking at Kotlin, it's just like even more similar. Like you could almost like copy and paste. Like I honestly kind of did for some view models. Like I would copy Swift, comment it out, and then just like change. I say that and then people are like, why didn't you write a script for that? It's like, probably should have. But you just literally swap out like subscribe for like observe on or like signal for observable. So that was a really cool workflow.
That is so cool. I mean, I've actually very recently been doing a lot of research into kind of like more theoretical stuff with functional programming. And I know like, a lot of it is just like pushing side effects as far away as you can. And, usually when you hear about that, people talk about, easier to test, easier to maintain, conciseness, readability. But the idea that part of the advantage is that it makes it easier for you to do dual platform development is fascinating because, your core logic is so similar.
That's sort of our mantra. It's like we, like the whole write once, reuse everywhere principle is like a very good principle of just like good software development standards. And for us, it was just like write your business logic once, like reuse it everywhere. Why restrict that to one platform? I mean, a lot of this was driven from like our team being really into like these Haskell-y, like old school, I mean, not old school, but like mathematical principles. But like for us, like it was important for us as a small team it just speeds everything up if you can read each other's pull requests, if you can understand both code bases, even for onboarding. Like we had some interns, like it was just really cool to see that like all that we had invested, because it is an investment, like it's a learning curve. You're dealing with frameworks that are very mature. Like it's just a very different way of thinking about programming. And then you're also working with like the native APIs, like yeah, you can use a view pager in Android, but how do you do that like with a view model? And then like how can you test it? Like those are definitely huge challenges, but in the end now we have like very solid code bases where developing a feature now is very straightforward. Also in terms of bug fixes, like yesterday we had a bug fix where something was returning null and we realized that we were like not filtering for the right thing. Yeah, we had no crashes, no. But we had missed something in like a big refactor. And our workflow for that was, okay, like let's think what's wrong. Think about what might be wrong, what might be returning null. Let's go to the test file, write a test. And we wrote a failing test because we're like, okay, this is probably wrong. Let's script that out. You can like scaffold and like have mock like outputs and subscribers basically that hit the actual view model. The test failed and then we fixed it and the test succeeded. And then like you just feel that much more confident pushing stuff out. And also when you do big refactors, like if you already have a very solid test file for every one of your classes that holds very important business logic, like it's just like very, I don't know, for a team of like 2 people, it's like, okay, like maybe that took us like 20 minutes longer to like push, but like now we are very confident that the feature will be fine. And it's been 2 years and like our crash rate is still like crazy low. It's like below 0.01% or something.
That is awesome.
Which is like nuts, but it's also like, yeah, like it was worth it. Like, and now it's like such a part of our workflow that it doesn't even take up that much time because our tests are they're lightweight, like roboelectric unit tests. They run very quickly. They're fun to write, and yeah.
I guess to ping back actually, and I think that's really really cool that you have exposure with both Kotlin and Swift. And I've always kind of wondered how similar are they, and I guess what is your view on both languages compared?
Yeah, people might kill me for saying this, but like they're pretty much the same. They're not. They're just so similar, like Kotlin and Swift, that the differences, there are trade-offs to each one that sort of even them out. And like in general, the syntax is the same. Like you have a let in Swift for a final value. You have a val in Kotlin, like 3 letters, and then you still have vars. The way you demarc optionals is the same way. I think the biggest fundamental difference, or one of the biggest fundamental differences, is enums.
I've heard many good things about Swift enums.
Yeah, enums are just pretty magical in Swift. They help with so many things like routing or just defining types, and they just make types like super useful, and they help just make your app more strongly typed.
How different are they from, say, Java enums and what we have in Kotlin?
They're just not real. In Java, an enum is basically, I think of them as just like classes that hold like a bunch of like static ints or something that just take up way more memory for some reason, like, and just can do less too. I don't know. In Kotlin, enum classes still exist, and they're kind of cool. They can be used, but if you want to really like represent a Swift enum in Kotlin, like we've done some cool stuff representing enums using sealed classes, and I think that's what the docs suggest too. Kotlin has so many cool features like tail recursion that Swift doesn't have. Probably used a little less, but
oh really?
Yeah,
I didn't know that.
Yeah, you can just annotate a function, I think, as tail rec, and even in the IDE, like on Android Studio, if you write a tail recursive function, a little thing pops up and it's like, this is tail recursion. And like when I was working on that with like my fellow iOS developer, we were like, Swift does a lot of things really right. Playgrounds are amazing. It'd be cool if there was like a live Kotlin playground. I'm not sure if that's possible.
I've heard this from a couple of different people that they love a playground for Kotlin.
Yeah, playgrounds just make Swift so easy to learn, which is awesome. Like if anyone's getting started, like it's like if you have a MacBook, like Swift Xcode is already built in. Like opening a playground and just being able to do that is just amazing for Swift. For Kotlin, like it'd be awesome to have the same thing. Like the website has pretty good like Kotlin cones and like little snippets where you can just run code, but that's
But playground just like a sandbox where you can just like do whatever and just see it run.
Yeah, so you can just try out, but you can also like reach into like the Android APIs to like try and do stuff. That's sort of what Swift playgrounds do. Like they give you access to the entire like iOS. Yeah, so if you wanted to like make a little graphic or like make a little view and like animate it, like you can.
So you don't have to like say like have a whole test project or anything. It's just you just go in, grab an API and do something with it.
Yeah, so that's pretty cool. That would be pretty cool if Kotlin like worked towards that.
Yes, please. If anyone's out there is listening and has any ability to help us bring these things, that would be kind of awesome.
Yeah.
Well, if you are interested in things Kotlin-y or Swifty or Android-y or iOS-y, you should definitely come find Lisa on the internet. And where can they find you on the internet, Lisa?
You can find me on Twitter, and my handle is @luoser, LUOSER.
Awesome. Well, thank you so much for talking with me today.
Yeah, it's been great chatting with you.
And thank you all, and we'll see you next time. Bye. I can't believe the curtain fell. Did you see that? I was like, we were just talking still.
Yeah.
It's like, that was good. We were cool. I just like, that's of course right in the middle, but that's okay.